I bought a small pack of circuit boards that are single-sided, and they look exactly like what you see here. So this is a copper-cladded board. It's a couple thousandths thick, the copper layer on the one side. The other side is just this material called FR4 Bakelite. So apparently that's some kind of woven fiberglass bound together with an epoxy resin. So what we're going to do is see if we can burn in a circuit board design into this and actually have continuity where we want it and not have any continuity where we don't want it. Pretty simple in theory. So to do that, we're going to go to the Autodesk website and pull down their most popular reference design, which is some kind of level translator. So I did that and I opened it with a program called Autodesk Eagle. And this is what it looks like. So kind of complicated looking for a novice like me, but you can see there are, actually let's go to view, layer settings, and you can see there are a bunch of layers here and they're all visible right now. I'm going to hide them all. So on this, we're just going to make visible the top layer traces, the bottom layer, the pads, and the vias. Now, we only have a single-sided board, so I am not going to show the bottom layer. If we had that bottom layer, we would export that after the fact, probably flip it, and have to have some kind of registration mark on the front side of the board made to be able to put the backside in the correct position. But we don't have that, so we're not going to use it. So we're just going to show anything that's a pad, a via, or the top layer. So I'm going to say OK to that. And we're left with what we want. Now, if I go to this manufacturing tab on the right, we can see roughly what the board should look like when we mark it. Now, there is one difference. These traces should show up on the top surface of our board, and they look like they're sort of within the substrate here. So that's roughly what it's going to look like. Now, I'm not going to put holes in with the laser. I can do it in a couple seconds, but it kind of burns, and it doesn't seem like a great idea. It seems like it's better to have those drilled after the fact. So that's more or less what it's going to look like. So we're going to print this to a PDF, and then from that PDF, we're going to bring it into Illustrator. So we're going to choose Microsoft Print to PDF. I'm going to leave the scaling the same, and I'm just going to click OK. So you can see now that it's in Illustrator, we have a directory at the bottom that we want to get rid of, and it looks like we have a bounding box on the outside that we probably want to get rid of. So let's direct our attention to the right side of the screen where we see what layers are available in this file. And we can just sort of use the visibility here, toggle it on and off to see what we want to get rid of and what we want to keep. So I've toggled both of those off and we haven't lost anything that I actually want, so I'm going to select both of those and delete them. Now we can expand this clipping group and you can see right on the top of the list, I'll zoom in a little bit so we can see what we're looking at. So right here we have the outer bounding box. I'm going to get rid of that. We can add that later in EzCad to make hatching easy, and we can completely ignore it in Illustrator, or we could add it here, but for our purposes, I think I'm going to get rid of this one now. Now, these are drill holes, these little round, colorless strokes, and you can see these are pads, and we don't need to worry about any of it now because we already hid everything we didn't want in Eagle. So all we're going to do now, we can collapse this. Now, let's keep this in the center just so we can see what we're doing. Maybe zoom in a little bit. So you can see the paths. So they're a little bit nonsensical right now. We have just lines. So if we got rid of our strokes, EzCad wouldn't know what to do with this. We have a box and we have a line going into the box, just intersecting it. So that's a problem. But what we need to do here is highlight everything. So we already did that. Go to the object menu at the top, choose path, and then choose outline stroke. So that's going to put an outline around everything we've got. Now notice, let's go right to the center here. Notice that this trace is going right in here in a strange little angle and terminating at the center. So what we want to do is intersect these. So to do that, we use a tool called the Pathfinder. So if you look at the right side of the screen where my cursor is, you can see the first option is called Unite. So I'm going to click that. Now what's happened is we've joined everything, so we just have a path around the outline of our shape. So this is exactly what we want when we take it into EzCad. So I'm going to scroll back out. We can see the design as it sits. Now at this point, we could either draw a rectangular box around it and take it into EzCad, or we could do that later in EzCad. I'm going to just take this as it is, and note that fills don't go into EzCad, as everyone's probably aware. So I'm just going to turn the fill off. I guess I have to have that highlighted. And we should add a stroke so we can at least see something. So I'm going to hold Shift and click the down arrow, and I'll choose a black stroke, and we'll make that just a real light stroke, only so we can see. So that's what we've got. So I'm going to export this. So I'll click Save As, and we're going to use the same folder. We'll call it a test, and we're going to save that as an Adobe Illustrator 3 file. And it'll take a second. We'll choose 3, click OK. And now we're just going to bring that right into EzCad. Go to File, Import Vector File. That's our file right there, the test. It's in. Let's click the Put to Origin button. There it is. Now I said we have to put a rectangle around it or something so we can have some hatchable geometry. Let's draw around it. We can get pretty close to the traces. I'm going to move that up just a little bit. That's probably okay. Now let's select both objects in the object list by holding the Shift key, and we'll click this H to add a hatch. Now this is a hatch I already set up. It's going to be marking the outer contour. It's only going to be one hatch. I've used multiple hatches. I tried to use a cleanup pass. I tried to only take off a bit of the copper, and I mean all of the copper, but not touch the substrate. You can do that in small areas. It's tough to do that over a larger area. I'm sure somebody will work out some settings that you get a much better result. Maybe these boards are also on the extraordinarily cheap side, so who knows if it's just a little bit harder to do that, but I'm having better luck just burning into the substrate. That's probably not the ideal way to make a quality board, but it should make sure we don't have continuity anywhere we don't want it. So let's do that. We're going to enable this hatch. I am going to use all calc, one of the few times that I've actually used it, just because we have a lot of little features in here that we want to jump over, and I think it's going to be faster if we can sweep all of our geometry here in one pass. Unidirectional, just so it's probably the best quality we can get. I am going to use a crosshatch. This is going to be pen 0. We'll talk about that in a second. I'm going to do 5 total passes. My line distance can be anywhere from 0.025 to about 0.07, and I haven't seen huge differences in quality, but when I get into a larger area, it seems like it's better if I keep it tighter. I'm not going to use auto rotate, and this can be anything. I can start at 0 degrees. So I said we're not going to do any second or third hatch, so I'm just going to click OK to that and apply the hatch. And since we have the rectangle around it, it has left all of our little traces and pads untouched, which is what we want. So let's look at our pen 0 settings now. We have it set to 1 loop because we set our count over on the left side where we did our hatch. Our speed is set to 500 millimeters per second, power 90%, and just to reiterate, or if you haven't seen any of my other videos, I've got a 20-watt laser, and this has a 150 by 150 marking area. So that's 90% power, and our frequency is 20 kilohertz. So I'm just going to select it, and we will put our PCB on the center of our workspace. And we'll probably mark toward the top of the PCB. These are warped, so there will be some variation. I don't know if you can see that on the camera, but that's why we're going to burn into the substrate. So that's probably fine right there. We'll click stop, and this is going to probably take a couple minutes to mark. I'll put the exact time up, but we'll find out. So the actual marking is a somewhat slow, tedious process because you have to take several passes, and the hatching is kind of dense. So it's kind of interesting though when you're marking at normal speed. Now it doesn't really show up on camera, but you can sort of hear when it hits the substrate. It's a very different sound. I didn't have as much success detecting when I was hitting the substrate on even a small area like this, but I would consider it fairly large. I was initially testing my speed power settings on just like a 10 millimeter by 10 millimeter area, and there you could do all sorts of interesting things. You could actually use a outline of your shape, and you could use minimal marking on probably like similar settings, 500 millimeter speed and like 90% power, and maybe just like 3 passes, and you could actually shear off the copper and you can just pick it up as a sheet if you went around it a few times after the hatch. So that was kind of interesting, but this is actually about a 5.5 minute process, and we do get quite a bit of depth, and we are considerably into the substrate. Not so much that we're halfway through the PCB, but you can definitely see the fibers.
Okay, let's take a look at what we got. I'm going to bring the camera over. There it is, if I can focus a little bit. That looks pretty reasonable. Definitely burnt into the substrate. So I'm going to put a couple leads from a Harbor Freight multimeter on it and see if I can get the screen in here, so we can kind of see if we have continuity anywhere. So let's just pick up that pad. Oh, I can't see it, hold on. There it is. So I've got a pad and I've got the outer edge. We've got nothing. Let's go from something that's connected and say this to that. So that looks like we're okay there. And let's go another one to the outside. And let's see if I can, the traces are tiny, but let's see if I can pick one up and go to there. So that looks okay. So not so bad. It looks like it was actually effective. Now that's going to be tough to drill those holes. You have to have some tiny drills, but all in all, I'd say it was a success and it looks pretty good. We can also look at it under this little Coolertron microscope. So here's what we're doing. It's lit up very well. We're going to put it right under here and look at the screen. So there's our engraved, there's our traces. So if you can see the screen, you can see this is just, let me grab this pen. So this is just our clean copper area. I'll drag it down a little bit. You can see our cleared out area that was hatched, this very dark stuff, and then you can see our little pads and traces. So this is a pretty small example, but you can kind of see how well we burnt it. And if there's any excess copper, you'd be able to see it. And that was a problem I was having with a couple of tests prior to this. There would be, you know, a little bit of excess copper. There might be some over there on the left. You can sort of see right in, let me see if I'm right about there, beyond that trace. We can put the multimeter on that trace and on the outer edge and see if there's any continuity. So there's the outside, there's the trace. Yeah, there is. So I probably would need to be a little more careful here. Possibly I'd just extend the rectangle a little further beyond the trace to make sure I get it all. That's about it. But there's the concept. So hopefully that helps somebody. I know this is kind of a neat process to be able to do on a fiber laser, and a lot of people are doing it with ferric chloride and chemicals in a convoluted process with a CO2 laser. The nice thing about that is you don't destroy the substrate so easily, but the fiber laser will burn right through it. So just another option that there is out there. So if you have any questions, feel free to leave them in the comments. But before I go, I think I'll throw in a little bit of footage of one of the images I used for the thumbnail to this video. And this burn came out a little bit better. It was a little bit more of a complicated design, so it took quite a bit longer to mark. And you can see I tested it once in the corner and I didn't really remove any copper. And the one I tested up top here that just finished, I removed a ton of copper and it was pretty deep into the substrate. So that was a pretty good marking. But I did kind of refine my hatch after that, and I used a smaller design, as you could see from what we just went over in the video. So kind of interesting, but exact same process, just a more complex design. So again, thanks for watching.